Welcome back to Business Tonight. In our technology section, SensorFrame Incorporated is both the name of a company and the product it produces. The new technology allows users to bypass computer keyboards and manipulate screen images directly. The SensorFrame grew out of a research at Carnegie Mellon University. With your hand, you can literally grab, twist, or flip a graphical object on a computer screen. The three-dimensional use of computers excited NASA, who helped fund research into the project, believing astronauts may one day use SensorFrame to operate spacecraft. This is one of two major products invented by Paul McAvenny. McAvenny's newest invention is the video harp. It works through a combination of optics and electronics. Mirrors inside the harp bounce light around and reflect it into a sensor. Shadows from fingers create disturbances that are translated into digital signals. Those impulses are fed through a computer, creating musical sounds. The founder and inventor of SensorFrame and SensorFrame Incorporated, Paul McAvenny, joins us now from our Pittsburgh studio. Mr. McAvenny, welcome to our program. Let me first ask you to explain how some of this technology works so the layman can understand it.
Well, what we're doing, Ron, with the SensorFrame and with the video harp is providing a light source inside, in the case of the SensorFrame, inside what looks like a picture frame that fits over a CRT, over a video monitor, and your fingers block the light from the light source, and then we have a very clear image of the fingers. And the attempt here is to track multiple fingers, more than one finger at a time, so that we can let people manipulate graphic objects in the future when we do a 3D product to actually manipulate things in 3 space. And in the case of the video harp, of course, we look at musical gestures such as bowing or keyboarding or percussion or strumming gestures, and we send those off to a digital synthesizer.
All right, now what are some of the commercial applications for this technology? How do you see it being used in the future?
Well, in the case of the video harp, we have a musical instrument which can also be used as a conducting instrument. For example, if a person makes bowing motions, each reversal of the bow could draw out the next note of a stored score. So without having to really learn to play the instrument very well, a person could control the expression of an orchestra. That's the musical instrument. In the case of the SensorFrame, which is a two-dimensional finger sensing device, people can control panels projected onto the screen wherever you need more than one finger. In the case of three-dimensional gesture recognition, we envision a case where people have a sensor, what we call a sensor cube, in front of the screen, and well, let's say you want to sculpt a surface,
right?
And we might throw a sculpting tool onto the screen. We call that a virtual tool, and that tool will essentially translate between the motion of your fingertips and what you might call the business end of the tool that scrapes a surface or extrudes out more material onto the surface. And the implication of this is that we can allow people to take pre-existing shapes or designs and make very quick changes using their hands.
Right.
When you want to do something spatial, language is not very good for that.
All right, we have a caller on the line from Missouri. We'll get a quick question in here. Go ahead, please.
Yes, is your product being offered as a public offering and through a stock or private ownership, or just?
It's private ownership at this point.
Any plans in the future to go public with this operation?
We think that's at least a year off.
A year off. Mr. McAvenny, we do appreciate you coming by this evening.
Thank you.
Paul McAvenny, inventor of SensorFrame and video harp and founder of SensorFrame Incorporated.